Welcome to the Deep Dive, where we take on the most complex, cutting-edge source material and distill it into essential knowledge fast. Today, we are taking a fascinating dive into the absolute collapse of the barrier between an AI idea and a deployed, functioning application. We're talking about building powerful, autonomous AI agent systems that can think, act, see, and hear all without writing a single line of code.
It really does sound like hyperbole, doesn't it? But our sources confirm that the ecosystem isn't just mature, it's incredibly robust. And the crucial part, it's free.
Free.
For years, the gatekeepers of serious AI development were, specialized coders, big corporations with massive budgets. That gate has been completely removed. We've analyzed the blueprint for an entire free universe of no-code and low-code tools.
And this is the critical distinction we need to make clear right up front. We are not talking about simple single-prompt chatbot wrappers.
Not at all.
The promise detailed in this source material is the ability to build sophisticated, deployed systems. I mean, things like legal compliance analysts.
It's exactly. Or self-updating research platforms or creative multimedia generators that operate fully autonomously.
So the mission for this deep dive is to move beyond just, listing a bunch of tools.
Right, we're structuring the architecture for you. We are mapping out precisely how these disparate free tools, from visual builders to automation engines and local processing powerhouses, how they all combine to create complex functioning systems.
So whether you are a student, a startup founder, or a professional aiming for rapid process automation.
This is the roadmap, the accessible roadmap to high-powered AI development.
Okay, let's unpack this blueprint. We need to start where all systems start, the brain and the body. We'll begin with the foundational platforms that handle the heavy lifting of structure and logic. So when you build an application, you need two things. You need the visible structure, the shell, the user interface, and then you need the invisible logic that actually makes it work.
And these core builders, they tackle that essential scaffold.
Let's start with Lovable AI. The name itself suggests approachability, and its core purpose is, well, pure simplicity.
Yeah, it's about defining and building complete web applications using only natural language. You describe the application you want, and it generates the foundation for you.
What's genuinely transformative here is the speed, the rapid prototyping speed.
Oh, absolutely. For anyone who has ever spent weeks or months trying to get an MVP, a minimum viable product off the ground, Lovable AI is a massive accelerator. The source material really emphasizes its ability to auto-generate the necessary UI/UX and simultaneously create the fundamental back-end logic.
So it's doing both at once.
Both at once. It makes the components actually work together right out of the box.
So if I'm an entrepreneur and I need an internal tool, let's say a simple dashboard for my team to track daily metrics with an AI-powered summary feature, I don't need a designer. I don't need a front-end developer.
Nope. You literally just type out the requirements.
That's incredible.
You're outsourcing that whole initial development phase entirely to the AI. This is ideal for quickly launching and testing concepts.
And the output is a real functional prototype.
A functional, deployable prototype. Think about creating specialized customer portals or simple internal CRMs customized for a niche industry.
Or AI-powered internal dashboards, educational tools.
Right, for specific curriculum requirements. The ability to deploy those prototypes live is the key benefit. It shifts the focus from coding friction to actual user feedback.
But let's be the informed skeptic here for a second. Lovable AI is fantastic for the shell, for the MVP. Does the source material hint at its limitations? If my AI agent needs highly specialized custom logic or deep integration into proprietary systems, am I going to hit a wall?
That's an essential clarification. Yes, you will. Lovable AI excels at the structure and the basic logic loops. Where you hit the wall isn't really in the interface. It's in the sophisticated long-chain reasoning that characterizes a truly advanced AI agent.
Okay, so give me an example.
If your agent needs to decide, based on 5 different pieces of external data, whether to execute one of 3 different external API calls, Lovable AI's natural language instruction might become really cumbersome or just insufficient.
And that's the handoff.
That leads us directly to the next tool, which provides exactly that advanced logic.
This is where we hit the aha moment for anyone serious about building complex agents. If Lovable AI is the user interface, Flowise AI is the brain's critical nervous system.
It really is. It's a visual, node-based workflow builder designed specifically for AI.
Flowise AI is the powerhouse that lets you move far beyond simple conversational AI. It operates by letting you, drag and drop these nodes.
Exactly. Visual blocks that represent functions. You connect them to define the agent's logic, its memory, its interactions. This visual pipeline completely demystifies the complex multi-step orchestration that advanced LLM systems require.
Okay, let's get specific. What kind of power does a visual pipeline like this unlock that a standard prompt just couldn't achieve? Because connecting an LLM to an external API used to be a very specialized development task.
It's all about orchestration and statefulness. A standard prompt is stateless. It forgets everything after the interaction. Flowise lets you chain steps together.
So it's a sequence?
A sequence, right? First, check the user input. Second, retrieve related knowledge from the vector database. Third, pass the input and the retrieved knowledge to the LLM. Fourth, take the LLM's response and format it using an external API. You can just keep going.
That orchestration is the definition of an agent. And the sources specifically call out its capability to integrate memory via vector databases.
Which is the key to RAG, retrieval augmented generation. Correct. RAG systems are what transform a generalist LLM into a knowledgeable expert. Vector databases store embeddings, these numerical representations of knowledge. Flowise provides the interface to visually define that whole RAG process.
So instead of trying to code that connection,
you just draw it. Imagine trying to build a legal agent. It needs document memory, the ability to search and synthesize information across, say, tens of thousands of specific legal precedents or internal company policies.
With Flowise, you just visually connect your core LLM node to your document loader node and then to your vector store search node.
And that's it. It's connected.
That immediately gives us these really powerful practical examples. We can build legal agents that pull from specific document sets or sophisticated research assistants that remember all your previous searches across a session.
Or automated email responders, ones that can search a customer's entire historical database before drafting an accurate, personalized reply.
And crucially, Flowise connects to webhooks and databases. This integration means the agent isn't isolated, it's not trapped.
Exactly. If your Flowise agent calculates a complex business decision, it can send that result out via a webhook to an automation tool like Zapier or Make, which we'll get to in a bit. Flowise is the core logic engine. It determines what happens and in what order for advanced thinking agents. It's where you define the multi-step reasoning.
Okay, so for those just starting out or maybe needing a quick deployment for a very narrow use case, the sources also point to tools that prioritize sheer simplicity.
Right. ChatBotKit and AgentGPT.
These represent the quickest, most accessible entry points into this whole agent creation universe.
They're entirely browser-based, and they focus on goal orientation. You define a goal or a personality, and the agent attempts to execute it, often involving basic web searches or maintaining a defined conversational flow.
So if Flowise is like building the operating system, these are more like single-purpose apps.
That's a great analogy.
If I need a simple personal assistant focused only on synthesizing info from a few websites and then writing a brief report, I might start here instead of wrestling with nodes in Flowise.
Absolutely. They are excellent for creating agents with a defined custom personality and a really narrow scope of action. Think of them as dedicated microagents.
And they're perfect for testing basic concepts or creating specific content generators.
For sure. Social media content agents, bots that write basic articles based on recent news, or educational bots that are constrained rigidly to a small, predefined knowledge set.
The benefit is speed.
It's the highest velocity way to deploy a functional, conversational agent without any complex architectural overhead.
So we've established the structure with Lovable AI and the brain and nervous system with Flowise AI. But as we hinted earlier, even the smartest agent is useless if it's trapped inside its own platform.
Right. It needs to operate in the real world.
Now we need to give the agent its hands and feet, the ability to interact with the external world of SaaS applications, databases, emails, and forms.
These tools are the digital glue. They translate the decisions made by the Flowise brain into actual actionable steps in external applications.
And we have to start with Zapier.
Zapier is the industry standard for application automation. And it's a crucial component for the no-code AI builder because its free tier is actually generous enough to handle a substantial number of tasks. It's a viable starting point.
And when we talk about scale, the source material notes its integration with over 6,000 apps.
Which is just staggering. If you use a tool from Google Sheets to Slack to Shopify, Zapier can probably talk to it.
The core capabilities here are managing multi-step workflows, setting scheduled tasks, and integrating common inputs like form submissions and emails.
But for our purposes, the critical function is its ability to serve as the action layer for the AI agent. You can connect your Flowise or your ChatGPT agent output directly to a Zapier webhook.
Let's walk through a precise agent example to really illustrate the power of that connection.
Okay, imagine you have a custom-built research agent in Flowise. It's monitoring API feeds for sudden price shifts in specific commodities. When that agent detects a major shift, it sends a webhook payload, a little packet of data, to Zapier.
And Zapier's just waiting for it.
It intercepts that data and then executes a multi-step workflow, a ZAP, as they call it.
And what does that workflow look like in practice?
Step 1. Instantly update a specific cell in a Google Sheet labeled Urgent Alerts. Step 2. Draft a summary email based on the data provided by the agent and send it to the executive team via Gmail. Step 3. Post a truncated, synthesized version of the alert to a private Slack channel.
All three actions across three different applications are performed automatically, based entirely on the agent's logic decision.
That's it. Zapier is the tool that gives the agent the ability to act, to physically do things in the digital world.
That makes Zapier the essential gateway. But we know the free tier, while generous, has limits. The number of tasks per month. Is that the major friction point that pushes an advanced builder toward our next tool?
That is the exact friction point. As your agent grows from a prototype handling maybe hundreds of tasks to a full business operation handling thousands of workflows daily, those task limits in Zapier's free tier, they become expensive barriers.
And that is precisely where Madri steps in.
The source material positions Make, which was formerly known as Integromat, as the more powerful visual automation tool.
So when your workflows graduate from simple sequences to complex, branching, and high-volume operations, you move to Make.
Exactly.
What is the core technical difference that elevates Make beyond Zapier for the agent builder?
It really boils down to two things: logic complexity and integration depth. While Zapier excels at pre-built connectors that handle common interactions, Make gives you this incredibly granular control over the data flow and the logic itself.
So you can build effectively unlimited complexity within a single workflow.
Unlimited. You can build intricate branching paths, conditional loops, error handling mechanisms that are far more robust than what Zapier offers in its free or basic tiers.
You mentioned raw HTTP API calls. Why is that so crucial if I'm building a custom agent?
Okay, so if your agent needs to integrate with a custom niche service that doesn't have a pre-built Zapier connector.
Which happens all the time.
All the time. Or if you need to perform specific low-level data manipulation before it hits the target applicate, processing a raw file or parsing a complex JSON payload Make handles that natively with raw HTTP calls.
So you don't need to write a separate script for that.
It eliminates the need to write separate middleware code. It keeps everything inside that visual, no-code environment.
So Make provides the robustness and the customization needed for business-critical workflows.
Yes. Think business operations automation, high-volume lead generation pipelines, or multi-channel publishing systems that need to process content and instantly adapt it for LinkedIn, Twitter, and email campaigns, all while ensuring data integrity.
And you mentioned error handling.
The presence of sophisticated error handling is another key differentiator. If one of your external APIs fails, Make provides tools to define exactly what the agent should do.
Retry, notify an admin.
Or store the data somewhere else. This moves the agent's capability into true enterprise-level reliability.
Our final tool in the automation category, NON, introduces a non-cost factor that is equally, if not more important: data control and privacy.
Right, and it's facilitated by its open source nature.
This is a critical distinction for the informed learner. While Zapier and Make are cloud-hosted services, NON offers a free, self-hosted option.
And that means the actual execution of your automated workflows, the processing of your sensitive data, occurs entirely on your own server or machine. It removes any reliance on a third-party cloud infrastructure for workflow execution.
So who is the ideal user for NN? Where is data sovereignty paramount?
Any organization dealing with highly sensitive, regulated, or confidential data, think legal firms processing client briefs, healthcare providers building internal and administrative agents, or large educational systems managing proprietary student data.
So in geographies with strict data laws, or in corporations that mandate all data stays behind a specific firewall.
In those cases, N8N is the only viable no-code option.
The value proposition is total control and customization.
Absolutely. Because it's open source, it integrates seamlessly with other open source stacks, like the local LLM runners we're going to discuss in Part 4. This allows for a highly customized and secure architecture. The ability to inspect, modify, and host the code yourself means you have complete transparency and control over your agent's workflow execution.
Which is indispensable for high-stakes compliance and privacy-sensitive government or legal workflows. Okay, this completes the brain and the digital hands. Our agent can now think, define complex logic, and interact with over 6,000 external applications. But as we discussed, modern AI is multimodal. It needs to process and create media.
Right. If the agent can only produce and consume text, it's operating with one hand tied behind its back. We need to give our agents the power of sight, sound, and visual creation.
We're transitioning from pure data and logic to creative output. Let's start with visual creation tools that are accessible and, critically, offer high-utility free tiers.
We can empower our agents to generate visual assets on demand by leveraging 3 powerful free design tools, and each serves a slightly different purpose.
Let's start with Canva. I think everyone knows it for presentation slides, but how does its AI capability fit into our agent ecosystem?
Canva's strength is its ubiquity and its speed for utilitarian graphic design. For our purposes, its built-in AI image generation capabilities, which are available on the free tier, allow an agent to rapidly create necessary visual assets without any specialized graphic design skill.
So if an educational agent needs a quick presentation slide template, or a business agent needs a simple social media post with a catchy background graphic,
Canva provides that rapid high-utility generator instantly. It's the tool for volume and quick adaptation.
but then we step up in quality and hyperrealism with Leonardo AI.
Exactly. While Canva focuses on utilitarian layouts, Leonardo is focused on image fidelity. It's about generating hyper-realistic images, detailed logos, and complex character designs.
This is the tool an agent would use when the output requires real visual polish.
Right. For professional branding, generating book cover art, or creating high-fidelity thumbnails for a video.
And finally, Playground AI rounds out this visual trifecta by focusing on speed and abstract creativity.
That's right. Playground AI is noted for its ability to quickly produce artistic, abstract visuals and minimalistic designs. If your agent is tasked with creating conceptual art, generating mood boards, or producing designs that require rapid iteration on style,
Playground is the efficient, free solution.
right. By combining these 3, the agent can handle any visual need, from a simple chart to a highly polished brand mascot. The agent can choose the right tool based on the desired output quality and style specified in its logic flow.
Okay, what about video? Video is far more complex than a static image. How did these no-code agents tackle motion graphics and cinematic content?
The sources highlight the emerging capabilities of Pika Labs and Runway ML. These tools are rapidly democratizing video creation. They're offering capabilities to create short clips, apply cinematic transitions, and generate AI motion graphics, all based on text prompts or image inputs.
The application here seems like a step up in complexity. An agent would first have to synthesize content and then translate that into a visual script.
Exactly. Imagine an educational agent, which has already processed a lengthy research paper. The agent can then use a Flowise pipeline to summarize the paper into a 30-second script.
And then feed that script into Runway ML.
To generate a dynamic, captioned educational clip or a YouTube intro video. Or a business agent publishing marketing materials can automatically generate short promotional reels and podcast animations from text summaries.
It elevates the agent from a static text producer to a full multimedia content creation studio.
It does.
Now we give the agent ears and a voice. We start with the input side, audio processing. Whisper is consistently highlighted as the industry-leading transcription tool.
Whisper is an open-source marvel from OpenAI, and its importance to the no-code ecosystem is just massive. It provides near industry-leading accuracy in transcription, and its key capability is multilingual mastery. The sources highlight its ability to transcribe and, crucially, often translate diverse languages like Urdu, English, and Arabic with high fidelity.
This breaks down a huge barrier. An agent's functionality can now include summarizing from recorded audio, extracting key points from a spoken lecture, or generating meeting minutes, regardless of the language spoken.
Its real-world applications span these high-stakes and diverse environments. Consider legal environments dealing with recorded interviews or courtroom audios,
Or large universities processing diverse multilingual lecture recordings.
or international businesses automating the capture of meeting minutes and compliance checks across different global teams. Whisper provides the agent with the precise, usable, raw text input it needs to analyze and act upon.
So it's a crucial front-end component in many Flowise pipelines.
Absolutely.
And once the agent has analyzed the text, it needs to communicate audibly if required for voiceovers or accessibility. That brings us to Piper and Coqui TTS.
These are the engines that finalize the agent's output, text-to-speech. They allow for the creation of natural-sounding speech for voiceovers, professional educational content, and accessibility tools. The goal is to move beyond that robotic, digitized voice of the past.
So by integrating these TTS tools, the agent can deliver its findings or read back its summaries with high-quality, natural vocalization.
It completes the sensory loop. The agent can hear, analyze, think, create visuals, and then speak back its findings.
So we have the scaffolding, the logic, the automation, and the multimedia creative capabilities, all built using accessible, free tools. We've built the surface-level components. Now we have to dive into the engine room, the crucial underlying architecture that dictates privacy, cost, and long-term memory.
That's right. For maximum control, privacy, and true long-term knowledge retention, we have to understand how to run the models locally and manage specialized knowledge bases efficiently. This is where the cost truly drops to zero and the security goes up to maximum.
The idea of running a large language model, a system previously associated with huge data centers on a local machine, is a fundamental shift. Our source material points to Allama and LM Studio as the democratizers of this process.
Allama is the offline powerhouse. Its purpose is to simplify the setup and execution of large language models directly on your personal laptop or local server. This immediately addresses two critical constraints: ongoing API costs and data privacy.
And we're talking about running major high-performing open-source models like Llama 3, Mistral, Mixtral, and Phi 3. How does Allama practically achieve this on standard consumer hardware?
It streamlines the necessary virtualization and resource management. It handles the downloading, the configuring, and the execution of these large files. But the single most significant advantage for our no-code agent builder is the capability for local embeddings and local RB.
Let's elaborate on that. Why does local processing matter so much for an agent builder focused on professional or sensitive applications?
Data isolation is the key. When you run an agent offline, everything it processes, every document, every query, every result, stays entirely on your machine. You eliminate the regulatory and security risks associated with transmitting confidential data to a third-party cloud provider's API.
This isn't just about saving a few bucks on API calls.
Not at all. It's about meeting stringent compliance requirements like GDPR or simply maintaining corporate secrets.
So an agent handling sensitive client financial documents, or a medical agent processing anonymized patient data.
Or a government system restricted to an internal network. Allama is the foundation for all of those privacy-sensitive applications.
And it allows the agent to function without internet connectivity if necessary.
Exactly. It facilitates those high-bar, privacy-sensitive applications. And furthermore, local processing eliminates latency. Your agent can perform its complex reasoning and RE lookups instantly without waiting for round trips to a distant cloud server.
This is foundational power for the zero-cost agent builder.
It is.
And LM Studio serves as the user-friendly interface that ties this complicated local processing together.
Yeah, think of LM Studio as the graphical wrapper for Allama's raw power. It simplifies the entire process. It provides a user-friendly interface for finding, downloading, and running those local LLMs. And it bundles crucial features like our RAG configuration, integrated document analysis, and a simplified chat interface.
So it removes the need for dealing with complex command line configurations.
It truly democratizes the operation of these powerful models for the no-code learner.
Okay, we've used the term RAG retrieval augmented generation repeatedly. The retrieval depends on the vector database. For the non-coder, how do we define the role of the vector database in the simplest, clearest way, and why is it superior to a standard database for AI memory?
Okay, so a standard database uses keyword search. If you ask it for documents about apples, it finds documents containing the word apple. A vector database is different. It doesn't store words. It stores numerical representations of those words and concepts, called embeddings.
And this allows the AI agent to search for, what, conceptual similarity?
Conceptual similarity, exactly, not just keyword matching.
Give us an analogy.
Okay, if you ask a keyword database, find documents about the environmental impact of renewable energy. It might miss documents that only use terms like solar array pollution or wind farm footprint.
Because the keywords don't match.
Right. But a vector database understands the conceptual relationship between solar array pollution and environmental impact of renewable energy. It retrieves knowledge that is semantically similar, making the agent's memory far more intelligent, comprehensive, and persistent.
And the sources list several free options for this critical task, starting with Face.
Faces is developed by Meta and is noted specifically for its speed. It is a free tool designed for extremely fast vector search. This is critical for high-volume, real-time research applications. If you're building a system that needs to instantly search and synthesize across thousands of diverse, constantly updated documents, academic texts, legal filings, Face provides that necessary rapid retrieval capability.
And then we have the solutions focused on persistent storage and long-term knowledge. Chroma, Milvus, and Weaviate.
These tools are the foundation for persistent knowledge storage. They're designed to host the multi-volume knowledge bases that allow agents to evolve from generalists to experts.
So you could build a personal knowledge base based on every book, article, and meeting note you've ever stored.
Or a business intelligence system that manages continuous, multi-volume analysis of complex market data. The key is persistence. The agent doesn't forget information after the session ends. It stores it in these databases and retrieves it instantly for every subsequent query, enabling true domain expertise within your no-code agent.
This completes the core components. We've built the brain, the hands, the multimedia senses, and the secure, private, long-term memory. The last hurdle is sharing it with the world.
We've engineered a sophisticated machine entirely for free. Now, how do we deploy that machine? We need free, robust hosting solutions.
The expectation for deployment used to involve setting up cloud servers and configuring domains, which meant cost and technical complexity.
But the free ecosystem provides specialized hosting for every single component we've discussed. There is an incredibly generous ecosystem for free hosting because these platforms recognize that most AI projects begin as prototypes or educational tools requiring minimal resources.
Let's start with Riplet.
Riplet is a versatile tool. It's primarily used for hosting small application components or backend scripts. So if your complex Flowise agent needs a custom piece of Python code to execute a very specific data transformation before sending the data to Zapier.
Replit is an ideal, free place to host that minimal script and keep it running reliably.
Exactly. It's for hosting the small, customized logic elements that might not fit neatly into a Flowise node.
But when we talk about deploying the actual AI app interface, the front end, where users interact with the agent Hugging Face spaces, seems to be the specialized hub for the AI community.
It is the industry-standard deployment solution for AI interfaces. It makes hosting incredibly easy, particularly for applications built using specialized frameworks like Gradio and Streamlit. If you used one of these common Python libraries, which often integrate beautifully with Flowise Hugging Face, offers the one-click deployment solution. It is the public face of the open-source AI community and offers a generous free tier for running those interfaces.
And for deploying a more general, professional web presence, a marketing site, or a custom landing page for the agent, we look at Vercel.
Vercel provides a highly generous free plan focused on global web deployment. If your Lovable AI prototype needs a global professional web presence, Vercel handles the deployment of the static application front end seamlessly.
And it's often used in conjunction with Hugging Face.
Right? Where Hugging Face hosts the AI engine and Vercel hosts the polished marketing wrapper around it.
Finally, for the ultimate in speed and global performance, the sources highlight Cloudflare Workers.
This is for the agent builder focused on performance optimization and global reach. Cloudflare Workers allows for edge-based app deployment.
What does that mean exactly?
It means your application logic is distributed across Cloudflare's global network of data centers, minimizing the physical distance data has to travel. For globally accessible, high-speed, no-code applications that need zero-latency responsiveness, even if they are free prototypes, Cloudflare Workers leverages their free tier to provide global scale and speed.
This is an immense amount of material. We've covered foundational structure, complex logic, high-volume automation, multimodal creation, local processing, private memory, and free global deployment.
We have analyzed over 20 free high-utility tools, and the sources confirm the total absence of cost and coding skill as a barrier to building sophisticated professional-grade AI systems.
Let's synthesize this into the real-world power it represents. Run us through that multimodal educational compliance agent example again, but this time connect all the specific tools we discussed into a working architectural flow.
Absolutely. Okay, start with the input. An hour-long, privacy-sensitive lecture recorded in Arabic. The agent uses Whisper to transcribe the audio. That raw text is fed into a Flowise AI pipeline, which orchestrates the complex logic.
And the LLM itself.
The text is processed by an LLM, perhaps running privately and securely via Olama on a local server. Key data points and compliance risks are extracted and stored in a Chroma vector database for long-term memory.
And if it finds something?
If the Flowise agent detects a critical compliance violation, it sends a webhook to Make. Make executes a complex conditional workflow. It generates a summary document, uses Leonardo AI or Canva to create a high-quality visual presentation slide explaining the issue, and then uses Coquette TTS to generate a voice narration for the slide.
And where does the user see all this?
The entire interactive interface where users query the compliance database is hosted and deployed for free on Hugging Face Spaces, using Vercel for the main landing page.
That is a full-stack, enterprise-grade, multilingual, secure, RG-enabled multimodal system.
All conceptualized, built, and deployed using entirely free, no-code resources.
The complexity of the output is completely decoupled from the cost and coding skill required for the input.
And the sources confirm this ecosystem makes possible a vast new category of accessible agents.
Everything from personalized research agents, legal document analysts,
Creative design agents, educational systems tailored to individuals, sophisticated business process automation agents, healthcare explainers, compliance and tax agents.
and of course multimodal agents that interact across media.
The whole gamut.
So what does this all mean for you, the learner? The technology is here, the tools are free, and we've laid out the comprehensive knowledge of how to connect them. Since the only two barriers that existed previously, cost and specialized code, have been definitively removed.
The constraints on innovation are now purely constrained by imagination and access to quality data.
The field is level. The power has been distributed.
The future of AI development is open source and free to access.
Our final provocative thought for you to mull over. With the knowledge that you can build and deploy a sophisticated, professional-grade AI system right now, entirely for free, what complex application of AI, previously thought too proprietary, too expensive, or too difficult, are you going to tackle first with this new, free ecosystem? Go build the future.